Welcome to the next session, which is assessing logic. This session follows the comparing values, which we did previously. If you haven't done that lesson, go back to the lesson on comparing values, then come and carry on this one, which is called assessing logic. The logical operators most commonly used in Python programming are listed in the left-hand panel, which I'm going to type in straight away. Okay. These logical operators are used with operands that have Boolean values of true or false, or values that convert to true or false. So that's the outcome as you use this operand. Now let me just talk about the logical AND. The logical AND operator will evaluate two operands and return true only if both operands are the same. Only if two operands themselves are true. Otherwise, the operand will return false. Now let's see this in motion. In motion, let's set it in motion. First and foremost, let me very quickly type in the operands over here, which are and this is called the logical and the next one is or, which is called the logical or. Very important to know these things because they'll become very useful in deciding between different scenarios as you program, and you use this as an application to particular problems. And if you're doing loops, whiles, and many other decisions that you want to make, this kind of skill will help you as a programmer in Python. Now, those are the operands and or not. Logical and, logical or, logical not. Very important. Now let's put life to these things. What are we going to do with them? And as I demonstrate, you find it very useful. So before starting to demonstrate, let me put hashtags so that these statements are not executable. At least you have at the top and you know what we're referring to. So let's make some comments on the each of the operands. I've talked about the logical and. Uh, we said uh, we evaluate two operands and return true only if both operands themselves are true. Otherwise, the AND operator will return false. This is used in conditional branching where the direction of a program is determined by testing two conditions. If both conditions are satisfied, the program will go in a certain direction. Otherwise, it will take a different direction. And you can see this in the flowcharts as you do algorithm design. Now let's have a look how this works. I'll start, then I'll talk about the other one. I'll start the script. First, I'm going to make some declaration here. Declarations. It's very important always to do the declarations. Here, the declarations I'm going to make A equal to true, and I'm going to make B equal to true. Now, if you're following these word declarations, in order for it not to affect our program, I'm going to put a hashtag. Okay, so we have declared the two variables there. A is equal to true, B is equal to false. Then what shall we do? Let's put a statement. Here we're going to have a statement. Let me just type a statement. Now, the word statement in programming is the actual executable function that you want to do, what the program must do. Now, the statement is print. We're going to have print. In Python, print is the key function that you need to understand how it works. Without it, you cannot have anything displayed. Print, and logic. So there we go. And logic. So it's going to display the and logic. Now let's start doing the statements of importance here. Print A and A equals, so if this is true, it's going to give us true. So mind you, anything in quotation marks there will be displayed. So let's call the variable A and A. So what this tells us that I'm comparing the variable A to the variable A itself. So I expect the answer to be true. So let's run that. Yeah. And logic A and A, yeah. A and A, it's true because they both look the same. If I change, for example, if I just put B there and I put B there, I run, there's a problem there. What did I do? A and B, there's a problem there. It should return false. Oh, okay. Not. Let's press back there. A and B, we correct something there. Let me just get it back. It shouldn't have given us the true because A and B are not the same. Okay, because yes, it's correct because both these are true. I assigned it's correct. So it's correct. I assigned both these A and B. A is true, B is true. That's why it gave me true. So the program is correct. It's the assigning of my variables. The Boolean variable for B should have been false. Okay, should have been false. So let me try the first one. I beg your pardon, but you understand the concept. Okay, A and A should return true. Now, what about if I say B? B is not true, so this should fail. Very good. So and A and B, A and B, I beg your pardon, I'm comparing A and B. A and B false. So both these two are not the same, so it's false statement. You understand how this logic works. I was in a meeting somewhere with somebody, and we're talking about thinking, the logical thinking of computer programming. You got to be somebody who thinks in a certain way. It was a good joke, but it's true sometimes. Now let us look at that is the comparison of this. And let me just put all these statements print. In programming, I like if I'm going to repeat this printing. If I'm going to repeat it, I'll just do that, then change. This one is A and A, A and A, A and B, then A and B here. Okay, so I'm going to copy that and paste it. If you're learning to programming, keep typing over and over so that stuff can go into your brain. Then we have this B. So I'm comparing B and B. So you see what this works like. Now watch, print A and A. This is true because both operands are true. A and B will run out false because these two operands are not all true. B and B must be true because both these are false. Let's go. Yeah. So it is true that B and B is false because both of them are false. It is true that A and B is false because one of these is not true. It is true that A and B is true because both of these, the operands are true. You got to understand how this logic assessing works. Both these operands must satisfy a certain condition, which we assign there. Okay. Now, here we are going to try and practice this. Try and practice this over and over. So we've seen the statements and how they are coded and the evaluation of it. Now we are going to add statements to display the results of logical OR. This is the AND and OR. So let us go and put a statement of the this is print. We're going to say print logic, the OR logic. And when you start dealing with the assessing logic, it sounds a bit weird initially, but afterwards, when you begin to think programming language, it makes sense. It does make a lot of sense. If if you're putting this as a linear, you can put a little space there before stuff, but there's no list in front of it. They're all bullet points. Let's go and do this. Or print is not capital P. That would definitely fail. You come to print. This is, we are testing logical OR. Okay, let's see if I want to make this look neat. I'll put a backspace, little n. Let me just print so that it doesn't look. I'll put that. It's inset. Oh, it's inset. Yeah. Okay. Sorry about that. So I'm gonna print the first one. I'm comparing A or A equals my keyboard, yeah, equals. I put that one already, and I'm gonna call the variable or A. You got to practice a lot to get around this kind of logic. So in the same way, I'm going to do this statement 3 times. So we have that. Since we've run the other statements before, so we are comparing print A or A if or A or B. From repetitive use, you discover how these things work, and once you begin to understand, you'll be able to produce a solution to a programming problem. So here it's B and B. So both these, B or B. Now let's see what happens. Now, in order for us to have meaningful results, let me hashtag this one so that we don't execute things over and over. We've dealt with that bit already. I just want to hashtag them. Yeah, it's a logic we're dealing with. Let's see what happens. Run. Okay, A or A, true, because A and A, they are both truths. A or B, it gives us true. A or B. A is what? A is true. Yeah, so this should be true because we are choosing between the two. It's true. So B or B, we have false. Now let me explain on these ones. You see, unlike the AND operand that needs both operands to be true, the logical OR operator will evaluate its two operands and return true if either one of the operand itself returns true. If neither operand returns true, then the OR operator will return false. This is useful in Python programming to perform a certain action if either one of two test conditions has been met. Reflect on that. Play back several times on these comments I've made. Reflect on that. Now we're going to look at the logical NOT operator. And let me explain this before we proceed. Now repeat this after programming. The logical NOT operator is a unary operator that is used before a single operand. It retains the inverse value of the given operand. So if the variable a are the value of true, then not a would have a value of false. The NOT operator is useful in Python programs to toggle the value of a variable in successive loop iterations with a statement like a equal not a. This ensures that on each iteration of the loop, the Boolean value is reversed, like flicking a light switch on and off. With a lot of experience, you see that you become very much akin to this type of logic. Okay, so what I'm going to do, I'm going to hashtag all this so they don't execute. We are going to go to the next, let me see, which is the NOT. Okay, so you see the effect of the little n there is just to give us space from the boundary or the margin there. That's all it is. If you wanted to have that much space here, you can do the same over here. Now let's go and do that. I'll just copy one of these statements because I don't want to repeat typing what I can change so pretty quick. So the difference here now, we're going to do the print. Yeah, I need that statement there. I need that statement there, and I'll print it there, and I'll stick it there. Let me hashtag these ones. I don't want them anymore to be executed. Print n, not logic. Okay, that's what it is. Print a okay, I just doesn't help me to do. So a I call yeah, print a equals a, which is just going to call the variable itself for just for display. When you programming, you can decide what you want to display and not. It's open field, and I just want a little space there. T not a equal and not a, and let me also. So let's run that. Yeah, not logic. A is equal to not a false. Let me also do the second one. I've already explained this, and I'll explain it again so that you can understand. Well, when you play back this several times, you understand. The same way I'm going to do B. B is equal to B. B not B equals not B. Programming is an interesting environment. You've got to have, yeah, there you go. So we see the behavior of, let me just copy all this in case I get signed off here. So what we're saying that the logical NOT operator is unary operator that is used before a single operand. So we are looking at a single operand and it must return the inverse value of a given operand. I think inverse values, if you think mathematically, if I give you A, I want it to return 1 over A. That's the inverse, but in a different way of programming. So if the value of A are the value of true, then not A would have a value of false. So what we're saying that at the beginning there, you see we declared A to be true. So or not, so the not logic, if I call this A, the final answer I'm expecting will be false, which is what you say. A is equal to true originally, then the actual statement of the not will be false. In mathematics, simply, we are saying that if A is true, give me the inverse of A. Here to be 1 over A. That's what it's saying there, in mathematical terms. If value of B is false, what is the inverse of B? So if B is equal to 1 over B, if this is 1 over B, the inverse of 1 over B will be true. So B becomes the B. So go and look at inverse proportion in mathematics and use that as a learning tool to understand how the NOT logic works. So each time I have here, for example, if I've declared that to be false here, and that to be true, so the inverses will change. Let's try test true is true. Let's test this. So where you have true on this side, where you have true on this side become false. And this they swap as well because the declarations have changed. Print. There you go. A is now false. Its inverse must be true. The true values. Let's have a look. Let's just test. Let's do this. If it can, A is Q, B is T. Let's see what happens. Run. It doesn't work because these Q and T are not inbuilt Boolean values. So for this logic, it works with Boolean values. And Boolean values is false or true or false. Yeah. So if we do that, we see the answers flag up. They're going to be the opposite. If you've got a problem that you're going to be solving that requires for you to show the inverse or the opposite in Boolean, this is how you're going to use the logical operators. Now, if I want everything else to work, let's open up other statements. Let's see the finality of this program. So I open up on this. Mind you, these will be much more useful when you begin to do loops or branches. You're making decisions, comparing things, and then you want the program to go in the correct direction depending on the needed branch. Okay, this one is the print. This is the not logic. Not comments. Running comments are very important. This is not logic. This is running comments in programming are very important, or logic. This is the all logic. Excellent. You see, when programming, make sure you write neat. You break your program into parts that can, there you go. Can you see? This is beautiful. So this ends the assessing logic. Play this back and forth many times until you get it. The next recording will be on examining conditions. Thank you for watching, and I'll see you in the next tutorial.